Hello everybody and welcome back to Chopstick Maths. In this video, we will be learning derivatives of algebraic functions part 2. Now, the given problem is y is equal to root x. That is, we have to find the derivative of square root of x. Now, if you notice, this is not in the form of x raised to n. So, we'll have to write this in the form of x raised to n. So, we will make use of this particular property to write from the radical form to the exponent form. And here, nth root of x raised to m, where n is the order and m is the power, and it is read as nth root of x raised to m is equal to x raised to m upon n. So, we can use this particular property to write from the radical to the exponent form. So, square root of x, that is, the order is 2 and the power is 1. So, we can write this as y is equal to x raised to 1 by 2. So, y is equal to root of x can be also written as y is equal to x raised to 1 by 2, and this is in the exponent form. And now if you see, this is of the type x raised to n, and its derivative is nx raised to n minus 1. So, differentiating on both sides, we get dy by dx is equal to d dx of x raised to half. Therefore, dy by dx is equal to half x raised to half minus 1. Therefore, dy by dx is equal to half x raised to minus half. And using this particular property of indices, a raised to m is equal to 1 upon a raised to minus m, we can write this as dy by dx is equal to 1 upon 2x raised to half. Therefore, dy by dx is equal to 1 upon 2 root x. That is, x raised to half, we again write it in the radical form. So, the derivative of square root of x is 1 upon 2 root x. So, let's take up another problem. Y is equal to 1 upon 5th root of x cube. That is, we have to find the derivative of 1 upon 5th root of x cube. Now, if you see, this particular problem is not of the type y is equal to x raised to n. So, we'll have to make use of two properties. Firstly, we'll have to get this first in the exponent form, and then using the law of indices, we'll have to get this in the form x raised to n. So, let us first use this particular property, that is nth root of a raised to m is equal to a raised to m by n, where n is the order and m is the power. So, we can write 1 upon 5th root of x cube as 1 upon x raised to 3 by 5. As n is 5 and m is 3. So, using this particular property, we can write this as y is equal to 1 upon x raised to 3 by 5. Now, using this particular property of indices, that is 1 upon a raised to m is equal to a raised to minus m, we can get this in the form y is equal to x raised to minus 3 by 5. Now, if you see, this is of the type y is equal to x raised to n, and its derivative dy by dx is equal to nx raised to n minus 1. So, we can now proceed to take the derivative. So, differentiating on both sides, dy by dx is equal to d dx of x raised to minus 3 by 5. Therefore, dy by dx is equal to minus 3 by 5 x raised to minus 3 by 5 minus 1. Therefore, dy by dx is equal to minus 3 by 5 x raised to minus 8 by 5. And then further we can write this as dy by dx is equal to minus 3 upon 5x raised to 8 by 5. That is, the derivative of 1 upon 5th root of x cube is minus 3 upon 5 into x raised to 8 by 5. Now let us learn one more formula, derivative of a constant. That is, if y is equal to k, then dy by dx is equal to 0. That is, dy by dx of k is 0, where k is any real number. That is, derivative of any constant, that is any number, is 0.